Okay, well, let's take a look at some one-step inequalities. We're going to look at several examples. You should have the sheet that looks like this, and we're actually going to go into example one here. All right, and just so we're clear, we've got our greater than symbol, right? We've got our less than symbol. We've got our greater than or equal to symbol, and our less than or equal to symbol. And these are the inequalities, okay, because they don't equal. So we're going to do two different things we're going to do with this. We're going to actually solve the inequality, and then we're going to plot it on the number line so that we can show what that looks like, and make sure that we have a good grasp on how this actually works. Okay, so we've been solving equations, and um, that's been going well. But now we're going to just look at inequalities. And there's only a couple little changes every once in a while. There's a little bit of a slight difference in how it works, but not much. So what I'm going to do here, I'm going to zoom into examples 1 and 2. And what we're going to look at is we're just going to look at this first one, okay? It says W plus 2 is greater than or equal to 4. Well, we would solve an inequality the same way we would solve any equation, okay? So what I need to do is I need to isolate, right, the variable here. And I have this constant that I'm going to circle in blue that I want to get over to here or get rid of, okay? And the way I can do that is I'm going to show in red, right? Since we're adding 2, we're going to do the inverse operation. So if it's plus 2 or inverse, we're going to subtract 2, right, from both sides. When I do that, 2 minus 2 equals 0, so I'm left with just W. Okay, I'm going to bring down my sign, greater than or equal to. 4 minus 2 is 2. So W is greater than or equal to 2. And the way I'm going to show that, let's just do this real quick. For the sake of making it easy, I'm going to put -1 here, 0, 1, 2, 3, 4, 5. All right, so you can go ahead and do that. You should be writing down what I'm doing. So we're starting at 2 because it's greater than or equal to. And when we plot this, I don't know if you remember this, how you do this. If it's just a circle, that means it's greater than, right? Because it's not filled in. So it's saying, something above 2. But since we're saying or equal to, we're going to fill in this dot. So it's going to have this dot, and then we are going to, you can draw it right above, since the number line is in black and you're probably writing in a similar color. So we're going greater than. So which way is greater than? To the right. So we're going to say it's greater than or equal to 2. So that's how we would solve an inequality. And this might be like, how many of something do I need to sell in order to break even? Oh, well, anything greater than this amount, equal to or greater than this amount. So these are the kinds of examples that we would come across. All right, so this next one, example 2 is 3 plus x is less than 8. Well, let's see. What did I use for the last one? I circled so I'm solving for x basically. And I've got this constant here. So I want to move this out of here. And the way I do that is, like we did on the last one, inverse operation. It's the same idea. So I subtract 3 from both sides. Well, I end up with 0 plus x, right? Is less than, well, 8 minus 3 is 5. Or I could say it this way, x is less than 5. Well, let's go ahead and plot this. I'm going to just plot it somewhere in the middle. So we got like 5, 6, 7, 8, 4, 3, 2. Okay. And I said that it is less than 5, so it's not equal to 5. So I'm not going to fill it in. I'm just going to make this circle. And then I'm going to draw my little arrow. It's saying less than, so I'm going to head in the negative direction. So it's something less than 5. And that's how I'm plotting it on our number line. So now we've looked at two different ways to look at this. I've got my final answer. Actually, I'll just put a box around it. Put a box around this one too. And I've plotted it on the number line. All right, let's move on to example 3. And these are all still one, just single step inequalities, but you can use the same premise for um, two-step inequalities or multiple step. Same idea as you've been doing with the multiple step equations. So I'm looking at my constant here that I want to move over. So if I look at example 3, I've got h minus 3 is less than 7. Well, what's the inverse that I'm going to be doing? Inverse operation? Well, if I'm subtracting 3, I'm going to do the inverse, which is to add 3. If I add 3 to both sides, these just negative 3 plus 3, okay, cancel each other out because this is the same as saying plus negative 3, right? So I'm looking, this is all that inverse operation. It's also that additive inverse thing that we talked about before. So negative 3 plus 3 is just 0. So I'm left with h, right? That's the whole point, is just to get rid of this 3. Well, what I do to one side, I do to the other, right? We got to keep it balanced. So 7 plus 3 is 10. I keep my um, inequality symbol down. Make sure I bring it with me. Okay. So h is less than 10. Well, let's plot that. It's funny. I'm looking at my answer key and it's got something different. But h is less than 10. And what we'll do is let's put 10 over here. So 10, 11, 9, 8, 7, 6, 5. Got my thing. Okay, remember it's less than, so I'm not filling in the circle. And I'm going to go to the left because we're saying less than. And all of these numbers are less than. And it goes on infinitely. That's why I'm putting the little arrow. Okay, if it didn't go on infinitely, if it was like it's less than 10 but greater than 3, I would write something different. But we're going infinitely in the negative direction. All right, so that's the end of that one. Let's see. Let's go to example 4. So you've got that, and you should be catching onto the pattern now. So y minus 5 is greater than or equal to 9. Well, let's isolate our constant here, and so we can move it over to the other side. And the way we do that, inverse operation, plus 5. Well, negative 5 plus 5 is 0. Okay, we should be catching on to this pattern. All right, so we're adding 5 to this side. 9 plus 5 is 14. So y is less than or equal to 14. Well, let's plot that out. Let's do 14 here, 15, 13, 12, 11, 10, 9. All right, remember we're doing it is equal to 14 as well. So I'm going to fill that dot in so that I can represent that on the number line appropriately. We're going to draw our little arrow to the left because it's less than or equal to, and it goes infinitely in that direction. So now we're at y is less than or equal to 14. All right, this is where things start getting a little more interesting. Now we have example 5. 4n is less than or equal to negative 12. Well, I want to isolate n, like I always do. And in this case, we've got this coefficient 4. And I'm just going to remind you, if you want to write this out, 4 times n is less than or equal to negative 12. So you're welcome to write that so that it helps you remember what you're looking at. And then so you can do the inverse operation. Well, the inverse operation of multiplication is division, right? Because 4 divided by 4 just becomes 1, which leaves you with they just cross each other out, they eliminate. But what I do to one side, I got to do to the other. So I'm left with n is less than or equal to negative 12 divided by 4. Well, 4 goes into 12 3 times. When we divide a negative by a positive, we end up with a negative, right? So negative 3. We could plug this back in and see if that works. And this is what's really cool, and I didn't do this with these other ones, but let's just look at that really quick. So if n is less than or equal to negative 3, well, let's take negative 3. Does that work? Well, negative 4 times negative 3 is actually equal to negative 12. Okay, so that works. What if n was a smaller number? So 4, let's go negative 5, for instance. So 4 times negative 5, is that less than or equal to negative 12? Well, let's see. 4 times negative 5 is negative 20. Is that less than or equal to negative 12? Yeah, that's less than negative 12 for sure. So it actually works. You can see there. So let's plot this now. And because I'm going to just start with let's put negative 3 here. So negative 2, negative 1, then we got negative 4, negative 5, negative 6, negative 7. All right, equal to, so less than or equal to, so I'm going to start on negative 3. I'm going to fill it in because we said it could also be negative 3, and we proved that. And then draw my little arrow because that can go infinitely. Okay, because let's say negative 100 is 4 times negative 100. That'll be negative 400. Is that less than negative 12? Yes. All right, here's where things get a little tricky. Negative 6a is greater than negative 24. Okay, well, it should be inverse operation, right? Well, let's just try there. And we want to get rid of the negative. So I'm going to actually divide by negative 6, because if I divide negative 6 by negative 6, I end up with positive 8. Okay, so those cancel each other out. I'm left with a. Let's just do what we did on the other side. Negative 24 divided by negative 6. Well, what am I left with? I'm left with a 6 goes into 24 4 times, right? And the two negatives make a positive, so 4. And here's where things get tricky. If I leave this the same, will it still be correct? Well, if I said a is going to be greater than 4, well, let's see. If I put 5 in here, negative 6 times 5 is greater than negative 24. Well, is that true? Well, negative 6 times 5 is negative 30. Is that greater than negative 24? Well, no. What happens is when we are either dividing or multiplying a negative, what I got to do is flip. Okay, this is only when we're multiplying or dividing by a negative. We flip the sign. Okay, it flips the other way. Now, if we do it this way, if a is less than 4, well, let's try 3. Negative 6 times 3 is negative 18. That is greater than negative 24. So that works. So remember, flip the sign when you're dividing negatives. So, or multiplying. So let's just do this. Write it like this over here on the side. Multiply or divide a negative. Flip the sign. Okay? And that actually works when we see it like that. All right, I could have just divided by 6 and I would have had negative a is greater than negative 24, and that would have been true. But because I did this negative divided by a negative, I have to flip it. So let's just look at, let's just call this, let me zoom up, let's do 4 here. Oh no, let's do 4 right here. 4, 5, 6, 3, 2, 1, 0. And I'm saying that it is not, it is actually less than, so it's not equal to. So I'm going to just keep it a circle. Draw my little line here with my arrow, okay, that goes on infinitely. All right, let's move on to the last example. Oh, we got 2 more. So m divided by 9, all right, or m over 9 is less than 10. So now we're going, okay, so what is my coefficient I'm dealing with here? Okay, so I'm dealing with a 9, so I need to do an inverse operation with the 9 because I want to get m by itself, right? This is the part we want to isolate. So I'm going to multiply both sides by 9. Well, if I put 9m over 9, these just cancel each other out and I'm left with m, right? So m is less than 10 times 9, which is 90. Okay. I didn't flip the sign. And I didn't flip the sign because we weren't dealing with a negative. Okay? If we were dealing with a negative, we would flip the sign. So make sure that you keep that really clear as you're working with something. So m is less than 90. Well, maybe we should just check that really quick. Let's do, to make it easy, let's just do 9. So is 9 divided by 9 less than 10? Well, that's 1. 1 is less than 10. So I know I'm in the right vicinity. Okay? And then it should be less than 90. So if I put 90 in there, 90 over 9 is less than 10. That should not be true, right? Because it has to be less than, not less than or equal to. So if I divide, I get 90 divided by 9, I get 10. Is 10 less than 10? No. So we know we're on the right track here. So I'm just going to use 90 right here. And what the heck, we'll go by 5s this time. It doesn't really matter. We can do it however we want. 85, 80, 75, and 70. And I'm going to just take 90, and it's not equal to, so I'm going to leave that open because we're not filling that in. And then draw on our little line, and it's going to be less than. Got a lot of less thans. Are they all less than? All but one? Yikes. Okay. And then one last one. M divided by -5 is less than 6. Again, inverse operation. We're taking that coefficient, okay? That could be rewritten as -1/5 times m, but in this case we're just dividing. And we're going to do the inverse by multiplying both sides by that. So I'm going to multiply by -5. So put -5 on that side, and then I'm going to multiply by -5 over here. Well, these cross each other out. This becomes m. Well, because I'm multiplying by -5, I got to flip that sign, right? So 6 times -5 is 30. Well, it's actually -30. And m is greater than -30. Okay, well, maybe we should try this with something. Let's try 45. Something's kind of simple that works in easy. 45, which is greater than, oh, yeah, that's way greater than -30. Let's take 0, which is greater than -30. Let's go 0 divided by 5 is less than, sorry, by -5 is less than 6. Well, 0 divided by -5 is 0. Is 0 less than 6? Yes. Okay, so we know we're in the right spot. If it was flipped the other way, if the sign was flipped the other direction, then we'd really have go, no, that's not greater than 6. So we know we get the signs the right way. And we're saying it's greater than, let's just put -30 here. And let's just go by 10. So like -20, -10, 0, 10, -40, -50. All right. So how are we going to write this? Well, it's greater than, okay? It's not equal. So it is just a circle. And we're saying greater than, so we're going to go in the positive direction. Okay, we got to go in the greater direction. And there we go. So there's your examples. There, pull out for you guys to see the whole thing. And just make sure that you have reflected that in your on your sheet, and then you can fold it the way it needs to be folded and cut and glue it in and whatnot.